Hi everyone, thank you for joining. In this video we're going to solve another interesting integer equation that we are given that a, b, c, d and e are positive integers, and we want to find the values of a, b, c, d, e such that this equality holds, right? So if you'd like to pause the video and try it yourself first, then we could go over it together. Right, let's use the fact that a, b, c, d, e are real numbers, positive integers, so we can order them. That means we can say b is less than or equal to c is less than or equal to d, and that is less than or equal to e. Now clearly a cannot equal 1, because if a is equal to 1, left-hand side will always be greater than right-hand side. Now if a is equal to 2, the equation reads 2 to the b plus 2 to the c plus 2 to the d is equal to 2 to the e. Now if we divide everything by 2 to the b, so we have 1 plus 2 to the c minus b plus 2d minus b is equal to 2e minus b. But notice that we said c is greater than or equal to b, but notice in this case c cannot be greater than b, c has to equal b. And the reason for that is, well, one of the reasons, I guess one of the ways to see it, that if c is greater than b, then d is also greater than b, and e is also greater than b, right? So on the right-hand side, we have an even number, and then on the left-hand side, we will have an odd number, okay, which cannot be true. We could use a division argument as well, divisibility argument, but I think this is good enough. So in other words, now we can rewrite it as, since c is equal to b, we have 2 to the 0 plus 2d minus b is equal to 2e minus b. So that implies 2 plus 2 to the power of d minus b is equal to 2e minus b. If we rearrange that, we get 2 is equal to 2e minus b minus 2d minus b. So that implies 2 to the power of e minus b minus 2, d minus b minus 2 is equal to 0. If we factorize 2, we're going to have 2 to the power of e minus b minus 1, 2 to the power of d minus b minus 1, minus 1 is equal to 0. If we divide both sides by 2, we must have then this term here equal to 1. So in other words, we must have 2 e to the minus b minus 1 minus 2 d minus b minus 1 must equal to 1. But notice that if we are looking at 2 to the power of x minus 2 to the power of y, where x and y are positive integers, is equal to 1, what are the possible values x and y can take? Well, the minimum value of y is 0, and corresponding to that minimum value of x will be 1. So anything else, the difference will clearly be bigger than 1. So in other words, we must have that e minus b minus 1 is equal to 1 and d minus b minus 1 is equal to 0. That implies e minus b is equal to 2, d minus b is equal to 1. So in other words, we said c is equal to b, e is equal to b plus 2, and d is equal to b plus 1. So if we go back to the equation, we had 2 to the b plus 2 to the c plus 2 to the d is equal to 2 to the e. In other words, we have 2 to the b plus 2 to the b plus 2 to the, well, d is b plus 1 is equal to 2 to the e, which is b plus 2. So in other words, we found the solution, so the solution set is that. Right? Just to see that it is working, so when b is 1, we have 2 plus 2 plus 2 squared. Is it equal to 2 cube? Right? It is equal to 2 cube, isn't it? Or if b is equal to 2, we have 2 squared plus 2 squared plus 2 cube. Is it equal to 2 to the 4? And so on, right? Next, we suppose, now let's suppose that a is greater than or equal to 3. So the equation a to the b plus a to the c plus a to the d is equal to a to the e. If we divide everything by a to the b, we have 1 plus a to the c minus b plus a to the d minus b is equal to a to the e minus b. Now, similarly, we ordered these numbers to begin with. If you remember that we said that b is less than or equal to c is less than or equal to d is less than or equal to e, a similar argument to the previous part will show that c cannot be greater than b, right? If it is greater than b, then we could use, perhaps in this case, because we don't know whether a is odd or even, we could perhaps use divisibility argument that if c is greater than b, that means d is greater than b and e is greater than b. That means the right-hand side will be divisible by a, but the left-hand side will not be divisible by a because we're adding 1 to it, okay? So then we will say c must equal to b. So if c is equal to b, then we can rewrite this equation as 1 plus 1. If c is equal to b, that will just be 1 plus a to the d minus b is equal to a to the e minus b. So we have 2 plus a to the d minus b is equal to a to the e minus b. Since n is greater than 2 here, because we said n is greater than or equal to 3, that implies that we will only have a solution if d is equal to b, which means we have 2 plus a to the 0, which is 1, that's equal to 3, which is equal to a to the e minus b. So that implies a is equal to 3, and that implies e minus b is equal to 1. Notice that if a is greater than 3, we could again use a divisibility argument to show that there will be no solution here. So in short, if we have b is less than or equal to c is less than or equal to d, for n is equal to 2, the solutions are b is equal to c, d is equal to b plus 1, and e is equal to b plus 2. If n is equal to 3, the solutions are b is equal to c, b is equal to d, and e is equal to b plus 1. So these are the solution set. Okay, so I hope you enjoyed it. I hope you found it interesting and challenging. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.